So good morning to you. And our question here is explain the brief history of computers from the first generation to the latest generation. So we go straight to our work. And of course our topic is 3 generations of computers and presented by me, by name Derek. That's my registration number 23/U/0350. And now we go straight to our first generation, which was from 1946 up to 1957, and the main feature was the vacuum tubes. And the vacuum tubes, if you had to explain in simple terms, the electronic components used in early computers and electronic devices. And so the characteristics of the computers in the first generation, they had thousands of vacuum tubes, as I had explained earlier. They consumed lots of power, they generated a lot of heat, they are very large in size, they are very expensive since they are the first computers to be made. They used machine language, so the language was machine friendly compared to user friendly. They did 5,000 additions per second and 350 multiplications per second. And in the examples, we have the ENIAC, which is the electronic numerical integrator and computer, and you have the EDVAC, which is the electronic discrete variable automatic computer. More to the second generation, which was from the 1957 up to 1964, and the main feature was transistors. And if I had to explain the transistors in simple terms are semiconductor devices that serve as fundamental building blocks in modern electronic computers. And so the characteristics of the second generation computers, still they use transistors. They are smaller and faster than the first generation. They were cheaper and more reliable. They are more energy efficient. They still generated lots of heat. Still they used a lot of electricity. They used magnetic core technology, and they used machine stroke assembly language. And with examples, I can say we had International Business Machine 7090. We had the Control Data Corporation, which is 3600, and that is all for the second generation. Moving on straight to the third generation, which was from the 1965 up to 1971. Its main feature was the integrated circuits, and these integrated circuits, mainly the electronic circuits that contain a vast number of electronic components, which include like the transistors, etc., and many others. And the characteristics with these of the third generation computers, they used still integrated circuits, as I had explained, smaller and faster compared to the second generation and the first generation. They are cheaper than the second generation. They were accessed using a keyboard and monitor, so that means they were more user friendly compared to the second generation and the first generation. And in the third generation, that's why we saw the introduction of an operating system like Windows, the one we are using right now, Linux, etc. And they are made available to a large number of people compared to the first ones, because still these ones are cheaper and they are more accessible. So that means they are made so that they can be accessed by a large number of people. The examples you have the International Business Machine 360, and we have the Program Data Processor 11. Moving straight to the fourth generation, which spanned from 1971 up to date. The main feature is still the very large scale integration. And explaining typically what very large scale integration is, it refers to very many transistors embedded on a single chip. So that's basically what I can say about the VLSI. And the characteristics include microprocessor with very large scale integration. They use thousands of integrated circuits on a single chip, and that's what typically explains VLSI. And the first characteristic, they are small and portable. They are handheld devices, making it easier for people to move them from one place to another. They are more accurate. They are more accurate, and they are reliable. They have a larger memory. They have graphical user interface and application software. So the graphical user interface makes the computer more user friendly, like the user can easily use it compared to the previous generations where the computers were not user friendly. So the examples, we have the laptops, the ones we use in our daily lives. We have mobile phones we carry every day. And so now we move to the fifth generation, which is the future that we are seeing that is coming towards us. So the main feature we expect with the computers in the future generation is artificial intelligence. Artificial intelligence is software that can perform tasks that typically require human intelligence. That's basically artificial intelligence. And so the characteristics about the fifth generation, which we expect, they will have ultra large scale integration. They will be faster and cheaper compared to the computers we have right now. There will be introduction of quantum technology. There will be introduction of nanotechnology, and there will be very, very intelligent computers such that anything you ask, there will be anything you ask it to do, it will do, because there will be semi-automatic. Actually, there will be automatic, and there will be using the intelligence of artificial intelligence, which is uploaded in them to do the perform tasks that you command them to do. So that's all for computer generations, and that's it. So a good morning to you once again, and basically I'm going to talk about the evolution of the Intel X86. So according to our text here, it says that the Intel X86 is a popular family set of architectures used in most of Intel's AMD's processors. So the AMDs are the advanced micro devices, which are widely used in the personal computers we use in our everyday life and the servers. So the evolution of the Intel X86 processors spans several generations, and that's what you're going to talk about. You're going to see how they evolved from the first processor, the first Intel X86 processor that they made, up to the latest Intel X86 processor that we have right now. So some highlights include the following. So our first one is the 8080, which was the first world general purpose microprocessor. And the main thing about it was an 8-bit machine with an 8-bit data path to the memory. And so we got the next one, which was the 8086. So after the introduction of the 8080, they introduced the 8086, which was a 16-bit machine, and it had a wider data path and larger registers, which is the appearance of the X86 architecture. So this one tells us that the appearance of the X86 architecture right now, the general one, is that it has a large it has a wider data path and larger registers. And so after that, they introduced the 8286, which was an extension to the 8086 that enabled addressing a 16 MB memory instead of just 1 MB. That means it addressed a larger memory compared to the 8086. And so the next one, we had the 80,386, which was the Intel's first 32-bit machine. It was the first Intel processor to support multitasking, meaning it would run multiple programs at the same time. So this was a remarkable invention, because it enabled the processor to start doing multiple tasks and running multiple programs at the same time. So after that, they introduced the 80,486, which was, and here in the text it says that the 80,486 introduced the use of much more sophisticated instruction pipeline. The 80,486 also offered a built-in math coprocessor offloading complex and math operations from the CPU. That means, as the introduction of the 80,486 enabled the processor to start performing logical operations easily, because it offered a built-in math coprocessor which enabled offloading of complex math operations from the CPU. So that enhanced the processor to perform more efficiently. So after that, we had the introduction of the Pentium, where the Pentium, according to the text here, it says that the Intel introduced the use of superscala technologies, which allowed multiple instructions to execute in parallel. So that is all about the Pentium. It says that the Intel introduced with the Pentium, the Intel introduced the use of superscala techniques, which allowed multiple instructions to execute in parallel. So after the introduction of Pentium, we further went on to the introduction of the Pentium Pro, which continued the move into superscala organization, began with the Pentium. And so after the Pentium Pro, there was introduction of the Pentium 2, which incorporated the Intel MMX technology, which was designed specifically to process video, audio, and graphics data efficiently. So with the introduction of Pentium 2, it was more easy for the processors, especially the Intel X86, to process videos, audios, and graphics data more efficiently, which enabled the computers to run more efficiently. So after the introduction of the Pentium 2, there was the introduction of the Pentium 3, which incorporates additional floating point instructions. After that, there was the introduction of the Pentium 4, which included additional floating and enhancements for multimedia. So the introduction of the Pentium 4, on top of the additional floating point, it also added enhancements for the multimedia. So, and the multimedia, basically videos, audios, and graphics, as we had seen in the Pentium 2. So it had enhanced that for the multimedia. So after the introduction of Pentium 4, so we went on to the Core, which was the first Intel X86 processor with a dual core, referring to the implementation of cores on a single chip. So this was a remarkable invention, and one of the remarkable invention, meaning that this accelerated or gave path to implementation of putting more cores on a single chip. And so the latest we had about the latest version of the Intel X86 processors was the Core 2, which extended the core architecture to 64 bits. And more to that, the Core 2 Quad Pro provides 4 cores on a single chip, with more recent core offerings having up to 10 cores per chip. So from the introduction of the core and introducing the implementation of cores on a single chip, the Core 2 offered having 10 cores per chip, which would enhance more processing, and processing would become more easier. So in conclusion here, according to the text, it says that within 40 years after introduction of the X86 in 1978, it has continued to dominate the processor market outside embedded systems. So I think that's all about the Intel X86. And so we also move to the ARM architecture, which is also one of the architectures of the computer. And ARM in full is the advanced RISC machines. And according to our text, it says that the ARM architecture was developed by Acorn Computers in the 1980s, which is a family of the ARM architecture is a family of reduced instruction set computing, which is RISC architecture, used primarily in mobile devices, embedded systems, and increasingly in several desktop applications. So if I'm take you back, the Intel X86 processors, according to our conclusion, say that they have dominated the processor market outside the embedded systems. So beside the embedded systems, we have the ARM architecture coming in where it is usually used in mobile devices and embedded systems, and increasingly several desktop applications. So moving on, it says that the ARM processors are known for their power efficiency, which makes them suitable for battery-powered devices. So those include the phones we use, mobile devices, as you are saying, the laptops, because they are all battery-powered. So the ARM processors, the ARM architecture provides power efficiency, which makes it suitable to run in these battery-powered devices. So over the years, according to our text, the ARM architecture has evolved with different generations, such as the ARM V5, the ARM V6, the ARM V7, and the ARM V8. And moving on, it says that the ARM V8 introduced the 64-bit instruction set, which is the H64, alongside with the traditional 32-bit H32 instruction set, expanding ARM's capabilities to larger memory with more